Hey guys, in the last class we discussed about the curl of a vector field. In the present class, we will solve the problems based on the curl of a vector field. So what is the curl A bar? If A bar is a vector, then the curl of A bar is always a vector, and then that is expressed as del bar cross A bar is equal to determinant I, J, K, dou by dou x, dou by dou y, dou by dou z, ax, ay, az. Okay, using this formula, we can find out the curl of given vector field, right? If the curl of a vector field equals to 0, that vector is said to be irrotational vector. If the curl of a force vector equal to 0, that force is said to be conservative force. And one more point is any conservative force can be expressed as the gradient of a scalar potential function grad phi. If you consider the curl of this, del bar cross f bar is equal to curl of grad phi, curl of grad phi, that would be equals to 0. So the curl of grad phi equals to 0, where phi is the scalar potential function. If any vector is expressed as the gradient of a scalar potential function, then its curl value must be equals to 0. If del bar cross f bar equal to 0, then the vector f bar is called as conservative force, and that vector is called lamellar vector. Okay, so using these concepts, let us solve the problems. Right, the first problem: if r bar is a position vector, is a position vector, position vector, position vector, prove that del bar cross r bar equals to 0. That is curl r bar equals to 0. Right. So let us take the curl formula. Del bar cross r bar equal to determinant I, J, K, dou by dou x, dou by dou y, dou by dou z. Okay. R bar components x, y, z, x, y, z. That is equals to I cap into. So by neglecting the I column and row, then dou by dou y of z, dou by dou y of z, since partial differentiation 0, dou by dou z of y is 0, minus j cap into jth column and row, neglect and take the multiplication, dou by dou x of z 0, minus dou by dou z of x 0, plus k cap into kth column and row, neglect, dou by dou x of y 0, minus dou by dou y of x 0 equals to 0. So curl r bar is equals to del bar cross r bar, that equals to 0. The curl of any position vector is always equals to 0 if r bar is the position vector. Okay. Now the second problem: a bar is equals to 2x z square I cap, 2x z square I cap, minus yz j cap, plus 3x z cube k cap. Okay. Find del bar cross a bar at the point 1, 1, 1. This is the problem. Okay. First, you do the del bar cross a bar by using the determinant formula. I, J, K, right? I j k, dou by dou x, dou by dou y, dou by dou z, okay, and x component 2x z square, y component minus yz, z component 3x z cube, 3x z cube. Should write it into the determinant. Then simplifying that, that equals to I cap into dou by dou y of 3x z cube. That is 0 because partial differentiation. Dou by dou z of minus yz. Minus into minus gets plus y. We'll get y here. Okay. Minus j into dou by dou x of 3x z cube. 3x z cube. 3z cube minus dou by dou z of 2x z square. 4xz plus k cap into dou by dou x of yz 0, dou by dou y of 2x z square 0. Okay, so that equals to y I cap, okay, y I cap, the last term is also 0, minus y I cap minus j cap into 3z cube minus 4xz, 3z cube minus 4xz, okay, y I cap minus j into 3x z cube. Then we will write that so that continuation that equals to is equal y I cap minus j cap into 3z cube minus 4xz, 4xz. Right, sir. Now substitute 1 1 1 del bar cross a bar at the point 1 1 1 equals to, substitute x is equal to 1, y equal to 1, z equal to 1. So what you get? I cap, okay, minus j cap into here 3 minus 4 equal to I plus j, I cap plus j cap. 3 minus 4 minus 4 minus into minus gets plus. Okay, answer del bar cross a bar at the point 1 1 1 equal to I cap plus j cap. Right. Next, third problem. A force vector given, a force vector f bar is equal to I cap into z by y, plus j cap into c x z by y square plus k cap into x by y is a conservative force. Is a conservative force. Okay, conservative force. Then find the value of c, the value of constant c. Okay, so f bar given, it is given as a conservative force. If f bar is a conservative force, we know that del bar cross f bar equals to 0. So you equate the curl of this vector, the curl of this force vector to 0, then you will get the c value. Right? How to write it? Del bar cross f bar is equal to determinant I G, K, dou by dou X, dou by dou Y, dou by dou Z, F bar, Z by Y, X component, Y component, C, X, Z by Y square, it is X by Y. This is equal to, okay, yes, that equals to I cap into I in a column row తీసేయండి dou by dou y of x by y, dou by dou y of x by y, where x is constant, minus x by y square, okay, minus dou by dou z of c x z by y square. So there x and y are constant, minus c x by y square. Next, minus j into j in a column row తీసేయండి dou by dou x of x by y, 1 by y, minus dou by dou z of z by y, 1 by y, plus k cap into k ఉన్న column row తీసేయండి dou by dou x of this, dou by dou x of cxz by y square will get cz by y square minus dou by dou y of dou by dou x of dou by dou x of cxz by y square, cxz by cxz by y square. So what you get with respect to cz by y square? Yes. Into dou by dou y of z by y, dou by dou y of z by y, z. Okay, that must be equals to 0. If it is equals to 0, each component must be equals to 0. Each component must be equals to 0. Then x by y square is equal to cx by y square. Cancel, x cancel, implies c is equal to 1. C equal to 1. Answer C equal to 1 or minus 1. Minus x by y. Minus x by y square equal cx by y square. C is equal to minus 1. C equal to minus 1. This is the answer. So if this vector is equals to 0, if it is a 0 vector, a null vector, each component must be equals to 0. I am equating the x component equal to 0, then minus x by y square minus cx by y square equal to 0. From that, minus x by y square equals cx by y square. So x cancel, y square cancel, c equal to minus 1. Right? So this is one more model. The next question, prove that curl grad phi equals to 0. Important problem. Curl of grad phi is equals to 0. Right. First, let us write grad phi, sir, where phi is the scalar potential function. I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. Now you consider curl grad phi. Curl grad phi is equals to del bar cross del phi. Del bar cross del. So here del phi is one vector. This is grad phi. Del is another vector. It is one vector, it is another vector. Del bar cross del phi, you have to do. Okay. So how to do? Del bar cross del phi is equal to, same you take determinant method formula, I G K dou by dou x, dou by dou y, dou by dou z. Here x component of grad phi, dou phi by dou x, y component of grad phi, dou phi by dou y, It is dou phi by dou j. So that gives I cap into I ఉన్న కాలం రో తీసేసి ఇలా మల్టిప్లై చేయండి. డో బై డో వై ఆఫ్ దిస్ మైనస్ డో బై డో జెడ్ ఆఫ్ దిస్. డో బై డో వై ఆఫ్ డో ఫై బై డో జెడ్. డో స్క్వేర్ ఫై బై డో స్క్వేర్ ఫై బై డో వై డో జెడ్ minus dou by dou z of this dou square phi by dou z dou y. Okay, minus j cap into j ఉన్న కాలం రో తీసేయండి. So dou by dou x of this dou square phi by dou x dou z minus dou square phi by dou z dou x plus k cap into kth column and row neglect dou by dou x of this dou square phi by dou x dou y minus dou square phi by dou y dou x. So all these terms gets cancelled. That equals to 0. That is the 6. Therefore, the curl of grad phi equals to 0. Del bar cross del phi is equal to 0. Right. Now, next problem. Given a bar is equals to e power minus x minus yz I cap plus z j cap plus yk caps. Yk cap. Show that a bar is irrotational vector. A bar is a irrotational. Okay, irrotational. So we know that what is the condition required for the given vector to show the rotational? Its curl value must be equals to 0. Del bar cross a bar should be equals to 0. So let us find del bar cross a bar. If it is equals to 0, then we can say that it is a irrotational vector. I, j, k, dou by dou x, dou by dou y, dou by dou z. X component of this given vector e power minus x minus yz. Okay, y component of the vector e power minus x into z, right here, e power minus x into z. Z component of the vector e power minus x into y. Okay, so that equals to right, equals to I cap into dou y of e power minus xy. So then e power minus x minus dou by dou of e power minus xz, like this. What do you get? E power minus x minus j cap into jth column and row neglect dou by dou x of this. With respect to x, we are doing the partial differentiation, then y is constant. So then you will get e power minus x, y constant, again minus x, you will get minus here, minus e power x minus y, minus dou by dou z of this. Dou by dou z of this will get e power minus x plus y plus k cap into dou by dou x of this. Dou by dou x of that same minus z e power minus x. Next, dou by dou y of this plus z e power minus x. So all the terms gets cancelled. That gives 0. So del bar cross a bar equal to 0 we got. Therefore, the given vector a bar is said to be irrotational vector. If the curl of a given vector equal to 0, that vector is called as irrotational vectors. So one more problem. Given a bar is equals to 6xy plus y cube into I cap minus 2x square yz j cap plus 2y z power 4 k cap, so that x6 x5 plus y cube I cap, this is find curl a bar, at 1 1 1. Okay, how to do this? First you find del bar cross a bar using the determinant formula I J E dou by dou x dou by dou y dou by dou z, and here you write x component, that is 6xy plus y cube, y component minus 2x square yz, z component 2yz power 4. You do the expansion and then you substitute, then you will get a vector, then you substitute x is equal to 1, y equal to 1, z equal to 1, you will get the curl a bar value at 1 1 1 point. Okay, so that what you do, sir. I will explain one more problem. A vector a bar equal to 6xy plus y cube I cap plus 3x square minus z, 3x square minus z j cap plus 3z square minus y k cap. Find the vector a bar is irrotation. Prove that the vector a bar is irrotational vector. Problem. Prove that a bar is irrotational. A bar is irrotational. Okay. So we have to show del bar plus a bar equals to 0. Right. So now I am considering del bar plus a bar, I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, x component 6xy plus y cube, 6xy plus y cube, y component 3x square minus z, z component I'm writing here 3z square minus y, 3z square minus y. So here y is inside of 4 determinant. That is equals to I cap into dou y of, like this, dou y of 3z square y. The first term 0 minus 1 minus dou z of 3x square minus z. The first term 0, minus into minus gets plus, minus j cap into, okay, dou x of 3z square minus 5, 0. Dou z of 6xy plus y cube, partial differentiation 0, plus k cap into dou x of 3x square minus z, 6x, dou y of 6xy plus y cube, 6xy plus y cube. Here k cap into dou x of 3x square minus z, 6x, right? Then dou y of 6xy plus y cube, 6xy, dou y of 6xy, 6x, plus dou y of y cube that is 3y square. 3y square. 3y square. Mm, dou by dou x of dou by dou x, dou by dou by dou by dou z. That is one step. Here x component 6xy plus y cube, y component 3x square minus z, z component 3z square minus 5. First I cap into dou by of 3z square minus 1. The first term is 0, dou by of y minus 1 minus dou by dou z of this first term 0 plus 1. Okay. Minus j cap into, okay, dou by dou x of 3z square 0. It is also 0 minus dou by dou z of, okay, dou by dou z of this also 0 plus k cap into dou by dou x of this, dou by dou x of 3x square minus z, 6x minus 6x, okay, dou by dou y of this minus 6x plus 3y square. It is not equals to 0. Therefore, a bar is a rotational vector, not irrotational. Here a bar is, since it is not equals to 0, here a bar is called as rotational vector. Rotational vectors. Okay. Now, so in this class, what we did is, if the vector a bar is given, how to find the curl of this vector in terms of variable, and finding the curl of given vector at a particular point by substituting the coordinates x, y, z values, and showing that the vector is rotational. For that, we consider L bar cross A bar. If it is equals to 0, that vector is called as a rotational vector. If the force vector is given and asking the question, prove that it is a conservative force, then also we consider the curl of that force vector. If the curl F bar equals to 0, that force is called as conservative force. Okay. So in this model, you practice some more problems and get the concept.